Good morning, everybody. I thought I would show you how to balance redox reactions in acidic solutions. The first thing that we're going to do is, as always, split these into their half reactions. You don't need to worry about who is necessarily oxidized or reduced. Instead, if you can just recognize kind of which formulas look alike on the left and the right, those are usually the ones that go together. And so I can tell that this guy, for instance, this one looks a lot like this one looks a lot like this one, and so I know that those two are going to go together. So what I'm going to do is write them in their half reactions. So we have S2O3, doesn't matter which one you, which half reaction you write first. So we've got S2O3. And then, of course, we have our S4O6. And like we've talked about previously, we want to make sure that we write these reactions on top of each other. So I'm going to write that one there, and I'm going to write this one here. So we've got our our hypochlorite ion. That's what that one is. And that's going to form our chloride ion. So to balance these, here is the trick. So what we want to do is start by balancing everything except for oxygens and hydrogens, okay? This is kind of the same balancing technique that we saw back in September of last year. But what we're going to do is I'm going to look here, and I'm going to balance what we call our lead element, which is, again, something that is not, it is the thing that's getting oxidized or reduced. And you can usually tell. Again, we're going to balance everything that we can except for oxygens or hydrogens. So following that, you can see, hopefully, that the first thing that we need to do here is put a 2 right there. And the reason why is obvious. We've got our 2 sulfurs there, but we had 4 over here, so we had to correct for that. And then, of course, the bottom equation, this equation right here, seems pretty good. Again, we haven't balanced for oxygens yet, but we'll get there in just a moment. So now that we're done, the next thing that we're going to do is we're going to add the appropriate amount of waters to account for any oxygens. Okay, I'll say that again. We're going to add waters to whatever side we need to balance for oxygens, because these are all ions that are in solution, and so water's there, and so we can use water. We can use what's there present to help us with this. So what I'm going to do, I'll write these in, let's say, green. So I can tell that I've got something going on here. I've got 2 times that 3 makes 6 oxygens on that left side, and well, check it out. We've got 6 oxygens on the right side. So that top equation is actually good to go. The bottom equation, though, is problematic. Notice that we have 1 oxygen there, but 0 oxygens on the right side. So we're going to have to account for that. The way that we can do that is by coming in over here, and we're just going to go plus. Well, the secret is how many H2Os do we need to add to balance oxygens only? And hopefully you can all guess that that's 1, because there's only 1 oxygen per H2O. So I just need 1 H2O, and then now notice that the oxygens are balanced. So at this point, we're getting pretty close, I think, to finally having this conquered. The last thing, I want you to notice that we have a problem, and that is that the hydrogens are no longer balanced. In fact, we created a problem, didn't we? So we didn't have any hydrogens before, but especially in this bottom equation now, we have gone ahead and thrown in 2 hydrogens. So how do we fix for that? Well, that's what this whole guy here comes into play. Remember that anything that is an acid, okay? So anything that is an acid, that means that we're talking about H+, this specific ions. Those ions are present. And so as a last and final step, we're going to add hydrogens to whichever side in either equation to finally balance out the hydrogens. So if I go in here now and do this, you'll notice I've got 2 on the right, so I need 2 on the left side, and there it is. So I've got 2H plus OCl minus forming Cl minus and H2O. Notice that's a balanced reaction. And then notice our top reaction, it also is certainly balanced as well. So these are now what we would say balanced for elements. But like we've talked about before, redox reactions also have to be balanced for charge, and these are not balanced for charge. So we need to fix for that, okay? And the way that we can do that is we can add up our total charges, and that can help us identify where and what side we need to add reactions to. So here we go. Notice that on the left side, I've got a charge of -2, but there's 2 of these, so that makes -4 overall on that side. But notice there's only one of the S4O6s, and it has a charge of, there's -2 there. So if we add electrons, which are -1, how many do we need to add into what side? Well, hopefully you were able to guess it. We need to add 2 electrons to this side so that we can appropriately get this guy to -2, which obviously sums together to get your -4 that we had on our left side. So notice that the reaction up top now is actually balanced for charge as well as elements. So it's actually fully done now, which is exciting. The next one is going to be just the same. We're going to go through this one and we're going to go, okay, so I know that I've got a +1 there, but there's 2 of them. And so add the 2 together, multiply the 2 together, and that gives you a +2 right there. And then we have 1 OCl, and it has a minus charge, and so that's just a -1 there. So if we add +2 and -1 together, we're going to get +1 in total on the left side, okay? Let me actually erase that, and I will just put that right underneath. So we've got a +1 overall on this side. And then on this side over here, we've got a -1 there. We've got 1 H2O, but it has a 0 charge, so obviously that's 0, and so we have a -1 there in total on the product side. We need to add -1s, electrons, right? To which side? Well, it's got to go on this side over here. So what we're going to do is add our electron. Oh, I don't want that one. We're going to add our electrons over here on this side. And so now this is a balanced half reaction. Let me erase some of this extra fluff right now so it's not in our way here. And okay, so a couple of quick points though. You'll notice that our last step, like we've talked about, is to add them together. But to add them together, like we learned, we need to focus in on our electrons only and make sure that when I add them together that they legitimately cancel. So if you could see, we've got 2 electrons there. We've got our 2 electrons there, which means that we don't have to multiply through by any number to get them the same, which is great. We can just now add these 2 half reactions together. And by the way, a quick little note, hopefully everyone sees this, but I would hope that you see this. Notice that this top reaction is giving off electrons, right? Electrons, it's losing electrons. So that would mean that this is my oxidation half reaction. Notice that this guy is gaining electrons, which makes it my my reduction half reaction. I just thought I would point that out to you. So at this point, now we can go through and add everything together. Remember, we add everything on the, we're gonna add everything together that exists on the left side. Everything gets just put together on the left side and the right side. So let's get going. So here we go. So we have our 2 electrons plus 2H plus. It doesn't matter the order that you write these. So plus 2 S2O3 2 minus plus OCl minus to form S4O6 2 minus plus 2 electrons plus Cl minus plus H2. Again, we add everything together. And then remember, we think of this like an equal sign, so we can go through and start subtracting or canceling things out that are the same. And so hopefully you see it. This guy here is about to go bye-bye. So this guy gets canceled out with this guy here. So that's nice. In fact, why don't we just put a nice, lovely red line through them. Let's kick it up a notch. There we go. So those guys are gone. And it doesn't appear that anyone else cancels, which means that we can now finally write our balanced redox reaction, which is 2H plus 2, this is technically the thiosulfate ion, there we go, I had a brain fart there, plus the hypochlorite ion to form S4O6, 2 minus, plus our chloride ion, plus water. And this is now our balanced, so this is now our balanced balanced redox reaction. And again, acidic solution just means that to balance the hydrogens, I simply have to add H+. Take care.